Before I start, I'd just like to say how great it was to receive so many encouraging comments from you guys on my last video, the workshop tour. It was my first video for a few months due to various commitments and the workshop build itself. So it was great to see so many people still engaged with what I'm trying to do here. Today, I'd like to have a look at several ways to determine if a mechanical watch is gaining or losing time, and to look at some of the methods used to correct or regulate a watch. But before I start, I would like to go over just a little bit of the basic theory. In most simple terms, a mechanical watch movement has a power source. This forces a train of gears to turn, and at the end of the train of gears is a locking device. And this allows or disallows the wheels to turn by locking them and unlocking them. This is called the escapement and is made up of several parts. The escapement has a means to regulate the locking and the unlocking of the gears in order for the gears to turn at the required speed. There have been several types of escapement, but the most modern timepieces will have a lever escapement, the Swiss lever being the most common, and that is what we'll have a look at today. The escapement is made up of three main components: an escape wheel, which is actually the final gear, the pallet fork, which performs the action of locking and unlocking the gears, and the oscillator, which controls the rate at which the pallets lock and unlock the gears. In order to regulate a watch, we need to control the rate of the oscillator in order for it to unlock and lock the gears faster or slower, depending on the need. The oscillator in a watch is made up of several components in itself, but we'll focus on two of those components for the sake of this lesson. The wheel, known as the balance wheel, and the spring, called a hairspring or a balance spring. Now, two things are very important to governing the rate of a watch, and that would be the dynamics of the balance wheel and the length of the spring or hairspring. Changing the dynamics of the wheel, even by a small amount, will drastically change the rate of the watch. But this would usually only be done during the manufacturing stage and perhaps other special circumstances. But when fine-tuning the rate of the watch, you'd usually need to effectively adjust the length of the balance spring. In most cases, this is a very easy job, as the design of the watch escapement provides a simple way to effectively adjust the spring's length. The regulator, it allows you to adjust the location of the curb pins along the length of the spring's terminal curve. And this will have the effect of lengthening and shortening the spring. Now, if the spring is longer, then the rate will be slower. And if the spring is shorter, then the rate of the watch will be faster. There are some watch movements that do not have a regulator. As an example, some Rolex movements will require the adjustment of timing screws fitted to the balance wheel in order to adjust the rate. The Omega coaxial movement also requires this method, whilst other movements may have weights which need to be adjusted on the balance wheel. Now, in these cases, it is not really recommended that you attempt to adjust the rate unless you're extremely confident, as the potential for damage is a lot greater. Also, misaligning timing screws or balance weights can cause further problems and may be causing different rates depending on the watch's position. This is known as positional error. To summarize, in order to adjust a watch's daily rate, you simply locate the balance assembly and determine if a regulator is fitted. Most mechanical watch movements will have one. And by adjusting the position of the regulator, you'll be moving the curb pins along the length of the hairspring's terminal curve in order to effectively lengthen or shorten the spring. And the closer the curb pins are to the stud, the slower the watch will turn. The further away the curb pins are from the stud, the faster the watch will run. So if you have any questions, please post them in the comments below. I'll do my best to answer them, either below or as additional content in next week's video. I'll continue this in the next video, where we'll have a look at how we can determine the current rate a watch is running at. And we'll do this by using either a stopwatch or a time grapher timing machine. And further on in this series, we're going to have a look at how we can use a timing machine to help to diagnose faults in a watch movement. So stay subscribed, and then you'll be able to get those updates. And this Friday I'll be posting another strip down and reassembly video. This time it's the Omega Chronostop, a particular watch that I really like. I also post updates on both my Facebook page and my Twitter account. So click the links in the description, and if you use either of those platforms, that may be useful for you. Also, please be sure to visit our website forum, which is www.watchrepairtalk.com. That's where we like to discuss watch repairs, talk about the industry, and show off our watch collections. So thanks for watching, and see you next time.